Welcome back to the Inequalities unit. Today we're going to be talking about identifying solutions to inequalities. So let's go ahead and get started with that right now. Before we start finding solutions to inequalities, we need to know what a solution to an inequality is. So there are two important things to remember. Number one, a solution is a number that makes an inequality true. Most equations have one solution, like x equals 3. But inequalities have many solutions, like x is less than 3, because in that scenario, any number less than 3 is a solution to an inequality. Now let's take a look at example A. So here we are at example A, and it says circle all the values that are solutions to the inequality. So the first thing we need to do is solve our inequality. So we're going to draw a wall down from our inequality symbol. Then we're going to need to distribute, so we'll distribute our negative 3 to our 2, our negative 3 to 14. Negative 3 times 2 is going to be negative 6x. Negative 3 times negative 14 is going to give me a positive 42. And then we're going to bring down our sign, bring down our 21, because we haven't done anything with those. The next thing we need to do is get rid of our constant. We're going to do that by subtracting 42 on both sides, because a positive needs to be subtracted by a negative. Positive and negative are going to cancel each other out, leaving us with negative 6x. 21 minus 42 is going to give me negative 21. Then we're going to bring down our sign because we did not multiply or divide by a negative. And the final step is to divide both sides by negative 6. Negative 6 divided by negative 6 is 1, or positive 1x. Negative 21 divided by negative 6 can be reduced as positive 7 over 2. Don't forget that we flipped our sign because we divided by a negative, so our sign now is going to be x is greater than or equal to, and the answer to our inequality is x is greater than 7 over 2. So now we need to circle solutions to that inequality. It might be helpful to you to turn this fraction into a decimal, since all of our answers are whole numbers down there. So in that case, we'd have x is greater than 3.5. So we're going to look for any numbers that are greater than or equal to 3.5. So negative 8, no. Negative 5, no. Positive 1, no. Is 3 greater than 3.5? No. 6 is greater than 3.5, so that's a solution. 11 is greater than 3.5, that's a solution. 15 is greater, that's a solution. 22 is greater, and 40 is greater. So notice we had more than one solution. Any number that was greater than 3.5 was a solution to this inequality. Now let's take a look at example B. Here we are at example B, and it says circle all the sets that match this description. All values in the set are solutions to the inequality. So we have to make sure that once we solved our inequality, that every number in the set is a solution to our inequality. So I'm going to start by drawing our wall down from our inequality symbol. As you can see here, we have variables on both sides. We have to get the variables on one side. We have to get the constants on the other. So I'm going to start by moving the x's. So I'm going to move positive 4x on both sides because I want to get rid of the negative coefficients. You're welcome to move whichever one that you'd like. Negative 4x and positive 4x are going to cancel. Negative 4x plus 1x, or positive 4x plus negative 1x is going to give me 3x. Bring down my 13, bring down my sign, bring down my 7. Now I need to move my constants by subtracting 13 on both sides of my inequality. Positive 13, negative 13 are going to cancel. Bring down my 3x, bring down my sign. 7 minus 13 is going to give me negative 6. And now I need to divide both sides by 3. I'm going to be dividing both sides by a positive number, so even though I'm dividing into a negative number, I am not dividing by a negative number, so my sign is going to stay the same. 3 divided by 3 is 1, or 1x. Negative 6 divided by 3 is negative 2. My sign stays the same, so I have my answer as x is greater than negative 2. Now that I have that number there, I need to determine if each number in the set makes that true. So my first set of numbers, negative 20. Is negative 20 greater than negative 2? No, that one doesn't work, so I don't have to check any of the other numbers in the set. I know that's not going to work. Is negative 17 greater than negative 2? No. Is negative 4 greater than negative 2? No. Is 0 greater than negative 2? It is, but the other two numbers do not match, so that set does not work either. Negative 15 greater than negative 2? No. Negative 1 greater than 1? Yes. 6 greater? Yes, but negative 15 doesn't work, so that set does not work. Positive 3 greater? Yes. 7 greater? Yes. 10 greater? Yes. All of those numbers in the set work, so that's the correct answer. Now let's move on to practice number 1. So here we are at practice number 1 and 2. You're going to be trying these problems on your own. Once you've completed them, you're going to bring them up to have them checked and then move on to the appropriate classwork. So that brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub, and we will catch you in the next one.